Book 5, Chapters 4 and 5 of 10 books on architecture. This LibriVox recording is in the public domain. Recording by Fredrik Karlsson. 10 books on architecture by Vitruvius, translated by Morris Hickey Morgan. Chapter 4. Harmonics. 1. Harmonics is an obscure and difficult branch of musical science, especially for those who do not know Greek. If we decide to treat of it, we must use Greek words, because some of them have no Latin equivalents. Hence, I will explain it as clearly as I can from the writings of Aristoxenus, append his scheme, and define the boundaries of the notes, so that with somewhat careful attention anybody may be able to understand it pretty easily. 2. The voice, in its changes of position when shifting pitch, becomes sometimes high, sometimes low, and its movements are of two kinds, in one of which its progress is continuous, in the other by intervals. The continuous voice does not become stationary at the boundaries or at any definite place, and so the extremities of its progress are not apparent. But the fact that there are differences of pitch is apparent, as in our ordinary speech in sol, lux, flos, vox. For in these cases we cannot tell at what pitch the voice begins, nor at what pitch it leaves off, but the fact that it becomes low from high and high from low is apparent to the ear. In its progress by intervals the opposite is the case, for here, when the pitch shifts, the voice, by change of position, stations itself on one pitch, then on another, and, as it frequently repeats this alternating process, it appears to the senses to become stationary, as happens in singing when we produce a variation of the mode by changing the pitch of the voice. And so, since it moves by intervals, the points at which it begins and where it leaves off are obviously apparent in the boundaries of the notes, but the intermediate points escape notice and are obscure owing to the intervals. 3. There are three classes of modes. First, that which the Greeks term the enharmonic; second, the chromatic; third, the diatonic. The enharmonic mode is an artistic conception, and therefore execution in it has especially severe dignity and distinction. The chromatic, with its delicate subtlety and with the crowding of its notes, gives a sweeter kind of pleasure. In the diatonic, the distance between the intervals is easier to understand, because it is natural. These three classes differ in their arrangement of the tetrachord. In the enharmonic, the tetrachord consists of two tones and two dieses. A diesis is a quarter tone, hence in a semitone there are included two dieses. In the chromatic there are two semitones arranged in succession, and the third interval is a tone and a half. In the diatonic there are two consecutive tones, and the third interval of a semitone completes the tetrachord. Hence, in the three classes the tetrachords are equally composed of two tones and a semitone, but when they are regarded separately according to the terms of each class, they differ in the arrangement of their intervals. 4. Now then, these intervals of tones and semitones of the tetrachord are a division introduced by nature in the case of the voice, and she has defined their limits by measures according to the magnitude of the intervals, and determined their characteristics in certain different ways. These natural laws are followed by skilled workmen who fashion musical instruments in bringing them to the perfection of their proper concords. 5. In each class there are 18 notes, termed in Greek phthongoi, of which 8 in all the three classes are constant and fixed, while the other 10, not being tuned to the same pitch, are variable. The fixed notes are those which, being placed between the movable, make up the unity of the tetrachord, and remain unaltered in their boundaries according to the different classes. Their names are proslambanomenos, hypate hypaton, hypate meson, mes, netisynhemenon, parames, nete dizogmenon, nete hyperbolion. The movable notes are those which, being arranged in the tetrachord between the immovable, change from place to place according to the different classes. They are called parhypate hypanon, licinus hypaton, parhypate meson, licinus meson, trite synhemenon, paranete synhemenon, trite dizygmenon, paranete dizygmenon, trite hyperbolion, paranete hyperbolion. 6. These notes, from being movable, take on different qualities, for they may stand at different intervals and increasing distances. Thus, parhypate, which in the enharmonic is at the interval at half of a semitone from hypate, has a semitone interval when transferred to the chromatic. What is called lichenous in the enharmonic is at the interval at the semitone from hypate, but when shifted to the chromatic it goes 2 semitones away, and in the diatonic it is at an interval of 3 semitones from hypate. Hence, the 10 notes produce 3 different kinds of modes on account of their changes of position in the classes. 7. There are 5 tetrachords. The first, the lowest, termed in Greek hypaton; second, the middle, called meson; third, the conjunct, termed synemenon; fourth, the disjunct, named dyseugmenon; the fifth, which is the highest, is termed in Greek hyperbolion. The concords, termed in Greek symphoniae, of which human modulation will naturally admit, are 6 in the number: the fourth, the fifth, the octave and fourth, the octave and fifth, and the double octave. 8. Their names are therefore due to numerical value, for when the voice becomes stationary on some one note, and then, shifting its pitch, changes its position and passes to the limit of the fourth note from that one, we use the term fourth; when it passes to the fifth, the term fifth. 9. For there can be no consonances, either in the case of the notes of stringed instruments or of the singing voice, between 2 intervals of between 3 or 6 or 7, but, as written above, it is only the harmonies of the fourth, the fifth, and so on up to the double octave that have boundaries naturally corresponding to those of the voice, and these concords are produced by the union of the notes. Chapter 5. Sounding vessels in the theatre. 1. In accordance with the foregoing investigations on mathematical principles, let bronze vessels be made proportionate to the size of the theatre, and let them be so fashioned that, when touched, they may be produced with one another the notes of the fourth, the fifth, and so on, up to the double octave. Then, having constructed niches in between the seats of the theatre, let the vessels be arranged in them, in accordance with the musical laws, in such a way that they nowhere touch the wall, but have a clear space all round them, and room over their tops. They should be set upside down, and be supported on the side, facing the stage, by wedges not less than half a foot high. Opposite each niche, apertures should be left in the surface of the seat next below, 2 feet long and half a foot deep. 2. The arrangement of these vessels, with reference to the situations of which they should be placed, may be described as follows. If the theatre be of no great size, mark out a horizontal range half-way up, and in it construct 13 arched niches with 12 equal spaces between them, so that of the above-mentioned achaia those which give the note nete hyperbolion may be placed first on each side in the niches which are at the extreme ends. Next to the ends, and a fourth below in pitch, the note nete dyseugmenon; third, paramis, a fourth below; fourth, nete synhemenon; fifth, mis, a fourth below; sixth, hypate meson, a fourth below; and in the middle, and another fourth below, one vessel giving the note hypate hypaton. 3. On this principle of arrangement, the voice, uttered from the stage as from a centre, and spreading striking against the cavities of the different vessels as it comes in contact with them, will be increased in clearness of sound, and will wake an harmonious note in unison with itself. But if the theatre be rather large, let its height be divided into 4 parts, so that 3 horizontal ranges of niches may be marked out and constructed, one for the enharmonic, another for the chromatic, and the third for the diatonic system. Beginning with the bottom range, let the arrangement be as described above in the case of a smaller theatre, but on the enharmonic system. 4. In the middle range, place first at the extreme ends the vessels which give the note of the chromatic hyperbolion, next to them those which give the chromatic dyseugmenon, a fourth below; third, the chromatic synhemenon; fourth, the chromatic meson, a fourth below; fifth, the chromatic hypaton, a fourth below; sixth, the paramis, for this is both the concord of the fifth to the chromatic hyperbolion and the concord of the chromatic synhemenon. 5. No vessel is to be placed in the middle, for the reason that there is no other note in the chromatic system that forms a natural concord of sound. In the highest division and range of niches, place at the extreme end vessels fashioned so as to give the note of the diatonic hyperbolion, next the diatonic dizeugmenon, a fourth below, third the diatonic synhemmenon, fourth the diatonic meson, a fourth below, fifth the diatonic hypaton, a fourth below, sixth the proslambanomenos, a fourth below, in the middle the note mis, for this is both the octave to proslambanomenos and the concord of the fifth to diatonic hypaton. 6. Whoever wishes to carry out these principles with ease has only to consult the scheme at the end of this book, drawn up in accordance with the laws of music. It was left by Aristosthenes, who with great ability and labour classified and arranged in it the different modes. In accordance with it, and by giving heed to these theories, one can easily bring a theatre to perfection from the point of view of the nature of the voice, so as to give pleasure to the audience. 7. Somebody will perhaps say that many theatres are built every year in Rome, and that in them no attention at all is paid to these principles. But he will be in error from the fact that all our public theatres made of wood contain a great deal of boarding which must be resonant. This may be observed from the behavior of those who sing to the lyre, who, when they wish to sing in a higher key, turn towards the folding doors on the stage, and thus by their aid are reinforced with the sound in harmony with the voice. But when the theatres are built of solid materials like masonry, stone, or marble, which cannot be resonant, then the principles of the Achaea must be applied. 8. If, however, it is asked in what theatre these vessels have been employed, we cannot point to any in Rome itself, but only to those in the districts of Italy and in a good many Greek states. We have also the evidence of Lucius Mummius, who, after destroying the theatre in Corinth, brought its bronze vessels to Rome and made a dedicatory offering at the temple of Luna with the money obtained from the sale of them. Besides, many skilful architects, in constructing theatres in small towns, have, for lack of means, taken large jars made of clay, but similarly resonant, and have produced very advantageous results by arranging them on the principles described. End of Book 5, Chapter 5.